Hi, in this video here, we're going to look at two very quick examples of solving by factoring and grouping. Use these techniques here when the equation doesn't appear to be of the quadratic type. What we mean by that is if it doesn't look like some number times some variable squared plus another number times the same variable plus yet another number. If it doesn't look like that, we're going to try factoring first. For example, let's solve x to the fifth equals 9x cubed. Well, if you first set equal to 0, we would get x to the fifth minus 9x cubed equals 0. It certainly doesn't appear to be the quadratic type, because I cannot write x to the fifth power as x to the third, the whole thing squared. Notice that I'm very serious about factoring. I did not say anything about dividing here. Please refrain yourself from dividing anything, including the variable x. In fact, you should never divide in any circumstances by a variable x, because x is a solution to the equation. If you divide out that variable, that means you're actually canceling out a solution or getting rid of a solution that would have been there in your equation. So do not ever divide out a variable. You can only divide a non-zero constant. Here, let's try to factor. The x cubed is the common factor because I can think of x to the fifth as x cubed times x squared. If I take out the x cubed from both terms, again, terms are separated by either addition or subtraction sign, I would then have leftover of x squared from the first term, and then the leftover of minus 9 from the second term. Then notice that this inside x squared minus 9 is actually a difference of two squares. I can further factor that down into a x plus 3 and x minus 3. And then kind of use this extension of the zero product property, which says that if you have a product of multiple things all equal to 0, then it has to be the case that either one of those three factors have to be equal to 0. That means that it's either going to be x cubed equal to 0, or x plus 3 equal to 0, or x minus 3 equal to 0. They don't all have to be equal to 0 simultaneously, but it have to be the case that one of those three has to be equal to 0. X cubed is equal to 0, that means right away x has to be 0. There's no other number when you cube it, it's equal to 0. X plus 3 equal to 0 tells me that x has to be negative 3, or x minus 3 equal to 0 tells me that x has to be positive 3. So you actually get three solutions out of this equation. You notice that, well, you started with a fifth degree polynomial. You should expect to actually get 5 solutions out of here. Turns out that you do have 5. It just turns out that the solution x equal to 0 appears 3 times. That's why you get 3 zeros as your solution, and you get 1 negative 3, and you get 1 positive 3. It does indeed give you 5 solutions to your polynomial. Next thing we try is grouping, and then we use this technique if there are more than 3 terms in your equation. In this technique, we look for common terms within pairs of things. For example, if I look at the first 2 terms here, they share a common term of x squared. And the third and the fourth term shares a common factor of 4. That tells me that this is how I'm going to group them. I'm going to put x cubed plus 3x squared inside the first group, and 4x minus 12 inside the second group. Here you actually have a choice. If you want to carry out this negative sign, then you need to be careful. If I do factor that negative out of my group, then I need to change the sign on my negative 12 there. So that becomes a positive 12 when I factor out that negative sign. Once you've decided which groups they belong in, then you just perform the factoring techniques. Take out the common term from the first group, that's x squared. I have leftover of x plus 3. If you take out the common factor of 4, but really is the minus 4, you have the leftover of x plus 3. This is equal to 0. Now we've reduced the problem from 4 terms into 2 terms. Now all of this is a term, and all of that is a term separated by the subtraction sign. We then look for common factors within those 2 terms, and it's fairly obvious that the common factor is the x plus 3 there. So I pull out the x plus 3 and have one big parentheses for leftovers, which is going to be x squared and then the minus 4. X squared minus 4 is a difference of 2 squares, so I can further factor that down into x plus 2 and x minus 2. I carry over the x plus 3 from the previous calculation. All this is now equal to 0. Using the zero product property, I can say that it's either going to be x plus 3 equal to 0, or x plus 2 equal to 0, or x minus 2 equal to 0. And these are really simple linear equations to solve. Right away, I get x equals negative 3 -2, and 2. And you notice that really it's just the opposite of what these numbers are. This makes sense that we get 3 solutions out of here because we started with a third-degree polynomial. I would imagine to get 3 real solutions out of this thing. And because we're dealing with the polynomials here without any fractions, all 3 solutions are good solutions. There are no extraneous solutions here.